Good afternoon. Hope you all are enjoying this beautiful, beautiful fall afternoon. I'm taping this here on Wednesday afternoon, and it is just lovely outside. I was going to clean my desk off this week so that you all would be so proud of me and you'd be able to see a clean desk behind me, but that hasn't happened, and maybe before the semester's over, I'll get that done. I did get the squeak out of my chair. It's not squeaking when I move now, so one thing at a time. Today we're going to be talking about acquisition and sourcing and architecture. And these come out of chapters 6, 9, and 10. Chapter 6 talks about architectures. Chapter 9 talks more about about the whole sourcing concept. And then the next chapter, chapter 10, I believe it is, talks more about acquisition, systems development, and things of that sort, project management. All of these are very highly connected, and that's why I kind of clump them together in a unit. The first chapter, chapter 6, talks about architecture and infrastructure. And again, as a general manager, you're not going to have to probably be involved in the extreme detail of developing technical infrastructures and determining the architecture, but you are going to have to understand the relationship between the business requirements and the infrastructure or the architecture. I live out here in the country, and my brother-in-law is the next house if you go on down the road here, and he's about probably maybe a little over a quarter of a mile, maybe a half mile from me down the road. It just so happens that the last KU, Kentucky Utilities, utility pole for this area is right about my house. So I'm the last person on this road that has power through the Kentucky Utilities organization. Beyond that, the people on this road have the what used to be the Henderson Union, RECC, and is it Big Rivers? I'm not even sure what it's called now, but it's the rural cooperative, the rural electric service. Because Time Warner is the cable company in this area, and they use KU poles and lines for their, to string their lines. If there's not a KU pole in your area, then you cannot get cable through Time Warner. You have to then have satellite or something other. We are too far from the little town of Clay to get DSL internet through the phone system there in Clay. And so my options are to have either satellite internet or the cable. And the cable, of course, is very much the best performer, the best speed, the most dependability, the most stable. And I'm able to get that because I am KU, there is a KU pole, so I can get Time Warner to string me some internet into my house. Right down the road, the very next person, my brother-in-law, they cannot get KU, they cannot get Time Warner cable, and therefore they have no option for internet other than satellite. So their internet is nowhere near the quality and the stability of mine. Now, what's that got to do with today's lesson? Everything. We understand about infrastructures and the architectures of the infrastructures for a community. You understood exactly what I was telling you about why I can't get DSL. I'm too far from the switching center. Why I can and my brother-in-law cannot get. So what I'm trying to show you here is how my computing, my internet, my networking, all of my information technology capabilities are different to those at my brother-in-law's house because the infrastructure does not allow for him to have the same capabilities that I do. Likewise, in an organization, if you don't have power lines and you don't have plug-ins and you don't have fiber optic cable, whatever you need for your particular business requirement or your networking environment or to hook this particular piece of hardware up, if you do not have the infrastructure in place, you are constrained and you can't do that. You can't take a bedroom and say, I can take this. This used to be a bedroom. My home has 4 bedrooms. And so as my children grew up and were empty nesting, I was able to take one of the bedrooms, and it's now my office. And it's at the end or the back of the house, and I can just shut the door, and it's my little world back here. And my husband has a little corner over in the office, but he doesn't need the office space that I have, because my work office is so far away from my home that I have to spend a lot of time back here. So I could change this into a bedroom with absolutely no difficulty. I don't have a phone configuration back here, though, in the way that I would need it, so I'm a little constrained on a fax machine. But other than that, I just said, yeah, this is now an office. Let me move out the bed and move in the bookcases. It's automatically an office. I already had the power that I needed, and maybe would have put in a little better lighting originally if it had started out as an office, and maybe not have had the bedroom looking ceiling fan. But in terms of constraining what I do, I'm able to do the work I need to do right back here. Now, what if I had decided, though, that I wanted this bedroom to be a bathroom? That's not going to work. There's no plumbing back here. And so it's going to be a little bit more major. It's going to involve putting plumbing under the floors and getting water lines and getting drain lines and getting vents and a lot of infrastructural changes. And there's always that possibility that there's something under the house, like maybe the plenums and the HVAC and, and heating and air conditioning and all that. Maybe someone might say to me, you know what, we're going to have to completely move all of your heating vents, or because of where your return air is, we can't do. And so I could absolutely be stopped in my tracks, or at least I could be looking toward a major project. It would have been much better if at the time we built the house, we said, you know what, when our kids are gone, we might want that back bedroom to be a bathroom. Let's go ahead and lay some infrastructure and get some piping down in that area, and let's avoid putting in something in there that would prevent that from happening. So we would look at perhaps future requirements and what we might need someday, and we would try not to preclude that. And if at all, we would try to go ahead and build the foundation for that. You understand this completely. You also understand that when you build a house, you have to tell the architect, do you want a 1-story home or 2 stories? Do you want a basement? Do you want 3 bedrooms or 5 or 6? Do you want a utility room on the main floor? How many baths, how big your kitchen, what type of appliances, gas, or, you're going to have to share that dream. And so the architect can understand what your needs are ultimately going to be. And the architect is going to draw the big picture and come up with a blueprint that allows your dream to be taken to reality. But he's not going to pick out, we're going to get an American Standard or a Kohler toilet, or we're going to get a Delta faucet, or we're going to get a Carrier heating and air, whatever. And I'm just coming up with these names. I'm not advertising for anybody. Those just came to my mind. But those things are a little more specific. But when the actual builders get in here and start developing the infrastructure, they'll decide what hardware and software and which kind of wire and cable and some of those things. But it will be in line with what the architect says. If somebody just comes in here and builds a house and just puts some drain lines where they want to and some water lines where they want to, then I may not be able to put my bath or my kitchen where I would have chosen. So I want you to see and just get that picture in your mind of the difference between architect, that's the big picture. And you'll have to excuse me, I'm having a lot of trouble with the shoulder, and so when I do my arms, I oftentimes have to catch it. Going to be having surgery in a couple of weeks, but I don't think it's going to impact you all. I'll let you know when the time comes. But anyway, so I think you're seeing that picture and you're understanding what I'm trying to say. Well, this is what we do with architecture in the organization. And when we're talking about the architecture and the infrastructure. We're talking about the capabilities for the technology, just like we would talk about, lights and water, and sewer, and things of that sort. You can't get sewer if there's not a sewer system that comes to your property. For example, you might have to go on a septic system because the infrastructure is not there for you to connect to a sewer system. So these are the kinds of things we're talking about. And the organization, it's very much a management decision, and it's very much about management and about the strategies of the organization. Those are the critical issues. What is the organization going to need to do? What kind of strategies do we have? Are we going to have an online presence, and we're going to sell our products online and do online analytical processing, or are we going to be completely brick and mortar? What kind of networking are we going to be doing or needing? How are we going to be connecting with not only our customers, but also our suppliers? So you see, there has to be that vision of who and what I am. We're a family. We want to be in a single family home. We would like a base, where are these things? These are the things that we want to be able to meet our customers on the internet. We want to be able to have a supply chain system that allows us to interface with all of our vendors. We want to be allowed to do thus and such. And so then we have the big architecture that puts in place the foundations that would be necessary for that. And then we would ultimately get down to the nitty-gritty of implementing that architecture by determining and purchasing maybe desktops and maybe servers and maybe different types of storage and different types of just all the hardware and the software, and determining where the data is going to be stored physically and how's it going to be connected. So we'll ultimately get down to the hardware, the software, the networking, and those things that are very specific. That's our infrastructure. And the important thing here is that our infrastructure allow us to do the things we need to do in our organization, that it does not constrain us. That's very critical. And that we're able to, if management makes a decision that they want to move in this direction, that they don't get stopped saying, you know what, we don't have the bandwidth in place for that, nor can we get it in the short term. It's like I want a new way to get from the east side to the west side of Evansville. The Lloyd is hateful and filled and wrecks on it all the time. I want a new way to get there. Well, that's going to take a little while. They're going to improve the interchange there at 41, where 41 crosses the Lloyd. That's going to take a while, and it's not something that we can just put in an order to the Department of Highways and say, could you get this done by next week or even by next month? It's going to take a long time. We don't want to find ourselves in a position where we are a year out rebuilding a foundation and an architecture and going a completely different direction. We don't want to be there. We want to have systems, an architecture, and an infrastructure. In other words, we want to have all of that in place so that we can go ahead and act in the manners that we need to act. Now, that's the big picture. As a manager, obviously, you need to understand that. You need to understand enough about the technology to know that certain decisions would have certain impacts. I don't remember if it's in your textbook or in another one that I read, because I do read so many textbooks, and I read a lot of outside material just to help me be more, to help me understand all of these concepts better and to help me keep up with the new things. But I was reading the other day somewhere, and it may have been in your textbook, about a manager that decided to use this sales automation where everybody's going to have a laptop and the salesmen are going to be able to get to their data when they're out in the field. It was, I think, insurance salesman or something, and that's all well and good. He just he didn't pay a lot of attention to the architectural decisions. He said, I'm not an IT person. That's above my pay grade. I don't have to know that, and I don't understand it and don't want to, don't care. And then he decides to make a decision about changing some processes for the way his salespeople work. And next thing you know, lo and behold, he is finding that he can't do this because there are constraints, and we're going to have to build another lane on the Lloyd to make that happen. And it's going to be very expensive, and it's going to be a long time coming. Whereas if he had just been involved back previous with all of these discussions and decisions, he could have been asking, now if we move in this direction, will that allow us at some point, if we choose to do this, will this, how many customers can, how fast can we grow, and how big can we grow before we run out of room? Can we constantly just add on? How much will it cost? How much time will it take? How big a deal is it? And should we lay the framework now? And that's part of the reason that it's hard to justify information technology spending sometimes, especially infrastructural and architectural. Number one, we don't like to do that because it's behind the scenes, and we like to spend our money on applications that we can see. We hate it when we have to spend all of our money, on termite control under the house that nobody sees. We'd much rather buy a new couch or new cabinets in the kitchen, for example. So they're not sexy decisions. They're not interesting sometimes. So sometimes they get pushed aside, and they're just not seen. But it's real critical that management be on top of this and understand it well enough that you can at least ask the appropriate questions, and that you at least understand the basic big picture concepts. Now, some of the things, let me back up and say that back in the 50s, we had a very centralized, these are the systems that we now call legacy systems. We didn't have intelligent terminals with processors that were smart. We had what we called dumb terminals. The box that sat, at our feet, whatever, or maybe there wasn't even a separate box, but the bottom line, we had a keyboard and a screen. And the keyboard was for input, and the screen was for output. And we didn't really understand what was going on, maybe, but at the time when you typed in something, it went out to the mainframe, and all of the processing was done there. None of the processing was done at the point of your local machine. Now, that's what we called centralized computing. All of the processing power was in one place. Now, that's because in those days we were pretty much doing counting. We were doing transaction processing. So these big machines just had to do the computations associated with the transactions and processing them, like sales and payroll and inventory and things of that sort. They were very structured, and they were proprietary. At that time, you built a system to work on your machine. They were not general purpose machines like, Excel, and we can use it on any PC. They weren't like that at all. So if you can imagine what management was like then and what security was like then, there was one huge computer. Put it in a room and lock the door and control the access, and you didn't have a lot of people getting to your computer. In terms of management, everybody knew what was going on, and if you had an application, it interfaced with the mainframe. So the management, the development, everything was centralized. So the right hand always knew what the left hand was doing, and there was no question. So it was easier to manage, and it was maybe even more cost effective in some ways, and easier to secure because it was all very centralized. But then we know that organizations continued to grow after the war, and on through the 60s and 70s. Organizations got very large and very far-flung and overseas, and so this whole span of control became a problem. We no longer could have one unit that's doing all of the processing or that is managing all of the processing. I'm not talking about the size of the computer. I'm talking about the span of control for the management. And so we found ourselves needing to decentralize. And so what decentralization often meant then would be little autonomous units, like this unit would act like its own little kingdom, and this unit, so we would have a bunch of little kingdoms, if you will, with maybe some degree of integration, but we certainly didn't have the networking capabilities that we have today. The infrastructures were constrained simply based on the technology that was available at that point in time. But we fast forward on into the 70s and 80s, and we saw the PC revolution, and so now it became the PCs were affordable, they were easy enough to use and understandable and powerful enough that they began showing up on people's desks, and I could actually do a lot of my own processing right at my own desk. So we had these and the big mainframes existing at the same time, and we had a whole new set of managerial problems and concerns. You know, how do we manage these far-flung, these decentralized, these laptops or these desktops sitting out here? Do we let people do it or do we not? Do we have, you know, who manages them? Do we let them develop their own apps? So as a manager, see, you had a different set of problems at that time that you had to deal with. But we fast forward some more and we move into the internet and the networking and the client server technology. Client server technology, and that's kind of the internet and everything today is based on that. We have servers, which may be a big mainframe and they may simply be another desktop somewhere. But we have servers that serve the clients. The client is what used to be that dumb terminal. It's our input and our output sitting on our desk. But the good news is we have an intelligent component now. Our computer is a processor as well, and it processes. So we have the capability for me doing part of the processing right here, but then reaching out to a distant server to do part of the processing. So a server exists to serve the client. Whatever the client asks of it, the server responds with. And the client, of course, does the asking and some of the processing maybe. The server, meets the needs of the client. So again, we have to have certain infrastructural and architectural arrangements and capabilities for this to happen. The software, for example, has to be written for the client and for the server, for example. So we have different development needs now. We have different security issues to concern ourselves with because we don't have centralized controls, and my goodness, so many people are accessing our systems, and a lot of our security issues are simply people making mistakes. Or insiders being malicious before we even start talking about the outsiders breaking in to our systems. But again, you can see how our architectures and infrastructures have changed over time. So as a manager, you've got to understand this evolution. You've got to know what are the architectural and infrastructural concerns and issues of the day, and it's incumbent upon you to make certain that you are communicating with the IT people and other management in such a fashion that the infrastructure and architecture will be not only adequate for today's businesses, but where you think you're going in the future. We have to always look ahead. Now, technology changes constantly, and you're not going to be able to say today, I'm going to need this in 15 years. But you are going to have to be able to understand today that technology is going to change tomorrow. We're going to grow. We're going to change. We're going to need competitively to do just like so many banks now understand and finally understood they had to get an ATM. And now it's just part of doing business. You've got to have an ATM. That has to be a part of your infrastructure if you're going to be in business. So you have to have the architecture that will allow that to happen at some point, or maybe by making architectural decisions today, you can make these future decisions a little less costly, when they come down the road. And so many of the ATMs virtually worldwide, the ATM was a Windows XP environment. And when Windows began to stop supporting XP, which was last April or the April before, I don't know, time flies. But anyway, this became an issue. A lot of people have had to completely tear out their ATMs and put in new ones. Some of them just had to upgrade, but some of them had ATMs that could not be upgraded. And so they had to completely, and it was more costly. So this is what we're talking about. As a manager, do you have to know how to set up a network? No, but you do have to know what types of what types of burdens you would maybe bring onto that network, what kinds of functions you would need from that network. What are you going to need it to do for you today and tomorrow and in the near future, and so that can be communicated, and we can make certain that we are building the infrastructure that will allow for these things to happen. So this chapter 6 helps you understand this movement from the vision to the architecture to the infrastructure, and it walks us through a lot of the issues. It on page 174, it gives you the components of the infrastructure and the common architectures there on page 175. Talks about this service-oriented architecture. And this is all going to run together as a part of when we talk about the cloud. But service-oriented, when we do things in a more modular fashion. For example, when I do Excel, if I want to use Excel today, I have bought the entire Excel. Well, I've bought the entire Microsoft suite. And some parts of it I use more frequently than others. Some parts of it I've never used and probably never will. But I have all of Excel here, and I call up the parts that I need from my processor when I want to do that. But how about a situation where, you know what, I need a payment function. Let me just go out onto the web and get that. I don't have Excel, and I don't need all of Excel. The only thing I've ever done in Excel is a payment. Let me go out and just get that service or that functionality. This is kind of what they're referring to here. And we know that we're moving to these server-based architectures, as I'm talking client-server, web-based, because the internet now is a huge network that is pretty much free and allows us all to connect to that big platform such that I don't have to develop my own network anymore. I can use the internet platform. And so these are some of the things. We see the words peer-to-peer. Well, a client-server is more of a server, a subordinate superior relationship. I serve the client. The server serves the client. A peer-to-peer is not, there's not a server. You both have equal, you're peers. You both can, you both have the same, you can share resources directly to one another. You don't have to go through a server. I'm not the server, you're not the server. We're both clients, if you will, or we're just peer-to-peer, and we both can carry it all out. Another thing I want to ask your attention to be directed to on page 177, BYOD, bring your own device, and the consumerization of IT. This is a huge deal now and a huge management issue that can really be a strain, if you will, or a burden on your IT group. For example, I have brought both my multiple phones, because over time we trade up, but I have brought in my Android phones, more than one, and I have brought in an iPad, and I have brought in a Kindle reader. All of these I have brought to my IT group on campus and said, make my email work on this. And of course they have to take the time to do it, because I want to be able to get to my email when I'm using these various devices. It's a little bit simpler now, but it was much more hateful a few years ago. But it still is an issue that we now have to deal with. And once we make those connections, we have more security issues to deal with. But more and more and more employees are demanding that they're able to work on their own phones or their own tablets, and they're able to carry them wherever they go. And so this whole idea of bringing your own device is an important one. And this idea of the consumerization of IT, where as a consumer I have a tablet, or I choose the phone I want, or I choose the tablet I want, and then I expect the IT people to make that work for me. It's like me as the consumer is kind of pushing those choices. So this is another management issue that we have to be very careful about. Your book talks about and walks you through an example of the Tennis Up group about how they might go from business strategy to business requirements to architecture to actual infrastructure and implementation. So make sure you've read and you understand that. Your book also talks about an enterprise architecture. Sometimes our architectures are, they're not exact. We're talking about in a more refined area, confined area. We're not talking about the entire enterprise. But if we're, we can be talking about an architecture that overarches the entire organization. Now, architectural principles are listed on page 181. This is a sample list, but we have to have some principles that constrain us. It's like our mission in our organization that defines who and what we are. If we didn't have that, we could decide to who and be whatever we wanted to, and we would get out of bounds, if you will. What are the boundaries? Well, first, we demand that it's easy to use. We demand a single point of view. Our general rule is we're going to buy, not build. Now, if there's some reason, like maybe it's something we get strategic value from, it may need to be proprietary, it may need to be built in-house, but that would also require that we have the money and the people and the resources, the other resources to build in-house. Speed and quality, we're going to emphasize time to market, and we're going to maintain quality. Flexibility and agility. So the bottom line is we're going to have these rules, these principles. And when we start to make our architecture and infrastructural decisions, architectural in this situation, we don't make decisions that go against this. We don't decide to go get a mainframe and move to a mainframe platform because we're in a client-server environment and we're just going to change back. We would have rules that would talk about the operating systems or the, on an infrastructural level. So we would have rules that we would stay within, and that's what we're talking about here on the principles. At the back of the chapter, it begins to talk about virtualization and cloud computing. We're going to very shortly be talking about outsourcing. The bottom line, when we develop systems in our organization, we can either write them in-house or we can buy them. We can make or buy. And we're moving into some Chapter 10 and some Chapter 9 materials. We can make or buy. We need a payroll system. Am I going to make this system? Are we going to develop it in-house? Are we going to go out and buy off the shelf and tweak? Or maybe even go out and have somebody to custom design a payroll system for me. So the first question, are we going to make or buy? Well, making is very expensive. You have to have a lot of software, hardware, people, time, money. It's a big deal to have the skills and the abilities to write big systems in your organization. Most organizations don't staff their IT like that anymore. I shouldn't say most, many. There are many that do not. Atlas Van Lines comes to my mind here in Evansville. I did some shadowing out there, and I was very surprised to see how much development they have going on. They have a huge development shop where they're developing a lot of their own applications, but then they also outsource some of their other applications. So this is just one example. But once I decide that I don't have the time, the money, the resources, nor the necessity, if it's not proprietary, if it's not giving me any particular advantage, there's no reason that I need mine to be extremely unique and proprietary and secret. I can do my payroll. I don't care if my payroll's just like Walmart's payroll. Who's it going to hurt? So I might decide then to do the buy. Now, when I buy, I can go buy something off the shelf that's already designed, or I can buy something off the shelf and tweak it, or I can pay somebody to develop this system for me, and that's a continuum of different ways. One of the things we talk about now is using the cloud, and the cloud is simply outsourcing part of our functionality. When I store things, my pictures are stored in the cloud. All of my files at home are stored in the cloud. And so I've outsourced my backup, if you will, to someone else. I'm letting this particular Carbonite, I'm letting them back up my computer and keep that backup for me, rather than backing it up myself on a separate machine and securing that. I don't have the time, money, nor the desire to do that. I pay them something very minimal, $50 a year or something, and it's all backed up. Not only can I go back and get it if I lose something? When I got a new computer, I just went to my cloud there and said, put everything that's up there right back on this one, and it was painless. I loved it. Worth way more than the $50 or whatever it is. I don't know how much it is. Not much. I pay a year. Organizations are doing the same thing. Now, why would we do this? Well, number one, it's probably cheaper, and I don't have to keep all of that infrastructure there. I can just go out and get that. I can get those services, software as a service. I can get infrastructure in the cloud. I can get an entire platform in the cloud. So again, it's a continuum. How much do I get at the cloud? At home here, all I do in the cloud is store things. I don't get any other functionality, in the cloud. I have my own software on my own processor. I don't go out in the cloud to get that stuff. Actually, some of my connections to the university I do, of course. But by and large, I have storage in the cloud, and that's my biggest cloud decision. But what I want you to see is that, again, we can go out in the cloud. We can get somebody to run our entire online business for us. We can do that. We can pay, somebody to, here's my name and address, throw me up a website, put my name and my phone number in it, make it be this color, and start selling my pencils. We can get a huge, almost all of that functionality out there. Or we can just get a service here and there. Or we can just get software here and there. Or we can just get storage here and there. And virtualization is simply where software replaces hardware in a way. In other words, instead of having another server sitting here with my storage, I have software that connects to a server out there, and that's where my storage is. So we've talked about virtual teams and virtual business. So we understand all of this, and it's all coming together. And cloud computing is just a virtual infrastructure that says we're getting. Why is it called cloud? Because when we used to draw pictures of our architectures and infrastructures, and we would say, there's a server here and a printer here and a desktop here, and then this is out here on the internet. We'd draw the little picture of a cloud. It's out in the cloud, and so that's where that comes from. It simply means it's residing out there on another server, and I want you to. I wanted to call, I believe, your attention, on page 182, near the bottom of the page, there is a paragraph that says, because enterprise architecture is more about how the company operates than how the technology is designed, building an enterprise architecture is a joint exercise to be done with business leaders and IT leaders. IT leaders cannot and should not do this alone, because virtually all business processes today involve some component of IT. The idea of trying to align IT with business processes is outdated, and it has to be done now concurrently. And so what I want you to get from this is the understanding you are not, I understand, maybe an IT person or a technical person. You're that business person. But as this states here, the enterprise architecture is all about what the enterprise needs the technology to do. And so it has to be a concurrent decision. Now, I look over on page 184, utility computing, which allows us to purchase entire capability on an ASNA. And this is just, cloud is a part of, when we're talking utility computing, that's what cloud falls under that. Much like the distribution of electricity, the vision of utility computing is that computing infrastructure would be available when needed and in the quantity that's needed. I can turn my light on for 5 seconds and turn it off, or I can leave it on for 5 days. And it's on demand. I get the utility I need. Likewise, if I need to go to the cloud for more service or for huge amounts more of storage on a split second, then I should be able to do that. Now, also on page 184, middle of the page, I want to call your attention to a paragraph that says benefits of virtualization and cloud computing are many. Businesses who embrace a virtual infrastructure can consolidate physical servers and possibly eliminate them. And they greatly will reduce their physical cost of the data center. Then there's no upgrade costs, no maintenance cost, no power cost, no electricity cost, and no physical space needed, and no servers needed for the storage. This network will be much simpler also because the virtual infrastructure manages that. And then it goes on to say, but the biggest benefit of virtualization or the speed at which additional capacity or provisioning can be done. In a traditional data center, as I said earlier, if we want to add a lane to the Lloyd, that's a big deal. Not even sure we can do it, but it involves acquiring property, it involves moving things and moving power structure, and it's a big deal. And this is what we're saying. With virtualization, I can just go out and get more terabytes if that's what I need instantly. So I don't have to pay for this huge amount when I'm not using it. I go get it as I need it. So this huge fixed cost becomes a variable cost, and it's much more a manager. Of course, that leaves us dependent on that third party, on that wherever the cloud is, on that network availability. It leaves us with a different set of security issues. So the picture's not all perfect. But as a manager, you have to understand the pros and cons, and you have to ultimately come down on the side of what works for you and for your organization. Your book talks toward the back about some real issues with we have to be concerned about adaptability. Are we going to be able to add? It says at a minimum the architecture should be able to handle expected technological advances. So we have to have an architecture that's adaptable, that's scalable, which means how well it can be increased or decreased if needed to meet the needs of the organization. And there's an example here where the system was set for 650 agents and was able to be increased up to 950, but no more. And so that may sound like a lot, but then if you get over the 950, you're done. You're dead in the water. Standards, of course, which are the rules, the common languages, the common rules, or whatever that we use. And different vendors have different standards, and this, of course, then impacts our ability to be compatible. How easily are they maintained? Some of things are reusable parts and things of that sort. Security, and we could just talk forever about this, but we know the more decentralized, the more access points, the more concern we've got. And the way we approach security is largely through a risk model. Just like the security of our car, we are willing to pay X number of dollars a month to insure my car so that if it gets wrecked or stolen, the insurance company will bear the brunt of that risk and they will give me back another car. So we can either bear the risk ourselves and say, well, there's a 10% chance that this will happen. If it happens, it will cost us this much, and only a 10% chance that's going to happen, so we're going to either transfer that risk by insuring it, maybe, or we're going to just bear that, absorb that risk, and take care of it when it happens because it's, I don't have tornado insurance. I don't have earthquake insurance, maybe, because I don't live in an earthquake-prone area, whereas I might have flood insurance if I live in a floodplain, and these are just some examples. So we can either transfer that risk by insuring, for example, or we can bear that risk, or we can then spend the money to secure against that particular risk. On page 190, it talks about the process of doing this. Now, having said what we've said, if we move up to chapter 9, we're going to find ourselves talking about sourcing. And I've already defined for you in a broad sense what we mean by sourcing. We're going to start off with that make or buy. And you can read this about some examples. There was a time when we had an outsourcing model that was very popular, where we would outsource to one particular organization, and we would outsource perhaps our entire IT group. You know, I'm not even going to send out my own bills. I'm not going to do my own payroll. Why don't I pay someone to do that? Or furthermore, why don't I just pay someone to pretty much run my whole IT shop? Let somebody else be my IT function, if you will. And these arrangements, we've learned a lot about them over the years, and some of them have been very, very successful, and some of them have not been. We've moved down through time as we've evolved into more selective outsourcing, where we may outsource just particular parts and pieces, and we may outsource to multiple vendors rather than all of it going to, say, EDS, for example. But there are a lot of examples in the literature, both historical and current, about outsourcing arrangements where we, and certainly as we are outsourcing some of our functionality and so forth to the cloud now. But the important thing is that when we outsource, we lose control. That's our biggest negative. If it's something that is proprietary and strategic of nature, we might not want to lose control of that. We do lose control, and but we typically outsource because we think, look, you are a company that does billing. You are a billing company, so you're going to have economies of scale, number one. You're going to have, hopefully, the best practices in place, because this is what you do. This is your core business. In other words, you're the experts. So if I let the experts do it under that model, you're going to do it better, probably, than I am. You're going to have better resources, better equipment. So you're going to do it better and probably cheaper because of your economies of scale and so forth. And I'm not going to have this big fixed cost and be staffed for peak. I just pay you if you send out 2,000 bills, then I pay you for sending out 2,000 bills. I don't have to have all of these employees that I'm paying benefits for and all of this equipment and things of that sort. So historically, we outsourced to let the experts do it, and because of quality, to let the experts do it because of money, to let the experts do it because that left me alone to do what was really my core work, and I didn't have to spend a lot of time or, well, a lot of any resources on this. And so these were the reasons to do it. On page 265, you'll see a make or buy questions and answers, so make sure you've looked at that. And then you'll see on 266 and 7 and 8, you'll see the pros and cons of outsourcing. And what we've learned, though, is that our outsourcing arrangements are what's critical. Our contracts are important. For example, when people took over entire IT divisions, they would take over lock, stock, and barrel, our equipment and everything, and they would pay us up front because they were taking our resources. So I would get some money up front, and then I would only pay you as you sent out my bills, as those costs were incurred. So the money was lumpy. So it was better for you to have a long contract because you didn't get your money as quickly. Better for me to have a short contract because I'm getting a lot of money right up front, and if this happens to not work, the quicker I bring it back, the easier it is to bring it back. And so that right away set us up, as opposing one another. It has to be a partnership, and they have to care. And if you're just using them, then, or they're just using you, there has to be a true partnership, because you are putting, even your payroll, you think, well, that's just a support function. Well, you let your employees miss a payday this week or get it 2 days late and see how well they work. See what happens to their morale. See what happens to your production, for example. So it's really, really, really important that we do well with the contract right up front, and that we take into consideration, I'm just assuming that you're going to have the newest and the greatest technology, and you're going to be, because you're a company that does this. Well, you better write it down. Don't assume they're going to do maintenance, or don't assume they're going to do upgrades, or don't assume they're going to do anything. You never assume anything. You write every bit of it down. And we have a lot of history out there to help us to guide and do a better job there. Ultimately, then, if I outsource, where? Do I do it onshore, with someone here in the United States? Do I do it offshore? And if I do it offshore, do I do it near Canada, or do I do it far, China? And there are a gazillion reasons why. Obviously, the labor cost in some of these countries is much lower than here in the United States, and that's why a lot of people outsource various functions and functionality to countries where there's a huge difference in those fees. We've already talked about cloud computing and why we would outsource to the cloud, because we can get scalability and relative cost, not fixed cost. I said that backwards. And all of, so we've talked about a lot of those issues, but when we're talking then about far shore and near shore and offshore and onshore, we have to be concerned about things like political stability. We have to be concerned about things like some of these countries don't even have electricity 24 hours a day. And what happens if they have some kind of an unrest, or what kind of laws and rules govern. And in other words, we have to think of the possibilities that could occur among our people there and how that would impact our business. We also have to think about cultural issues like time and holidays and religions and things of that sort. But even something as simple as the way we solve problems. Some cultures, you will not find a person usurping a superior or an older person. So if I'm older and I ask you to write this program thus and such, and you're younger than me, even if you're looking at it knowing that what I'm asking is wrong, you wouldn't point it out to me. Now in America, you'd say, no, Jennifer, that's wrong. If I do that, this won't work. But some cultures, they'll say, well, that's stupid, but I'll do it. And they'll never say a word. They'll just do it. And 1 o'clock in some cultures is 1:00 and 00 seconds. To other cultures, it's about 1 o'clock. It's 1:15, well, it's about 1 o'clock. No, it's 1:50. Well, So just all kinds of attitudes and the way they react to superior-subordinate relationships, the way they react to authority figures, their value systems. All of these things come into play, and that's before we start talking about the all-important language. And not just can I understand you, but am I misunderstanding, because not just can I hear and understand what your tongue is saying, no, but am I using words that are conveying the wrong thing to you, or am I conveying it properly or not? So your book gives you more information. It also talks about captive centers where we create up a subsidiary of our own in an overseas operation. But I think that most of this is pretty understandable, especially given what I said, as we talked about outsourcing, about cloud computing as well. Now, as we move into Chapter 10, we're talking about managing projects. Now, managing projects, what's that got to do with all of this? Well, because IT developing applications or programs are typically done in projects. And a project has a definite beginning and a definite end. And the people who work on a project are in a specific team, and they're on this team right now, and this team disbands when they're finished, and they hand off the completed product. It's not like, for as long as I work here, this is what I'm going to be doing. So there are some specific characteristics of teams that make teamwork obviously a little different. We also have to understand how to manage these projects because we used to not be as scientific about it as we are now. We have the Project Management Institute now, PMI, all kinds of academic journals, all types of learning and research going on about how to manage teams. But there was a time when we were less scientific with it. And these, if you will read in the literature and you go back, say, 10 years and then look at 5 years and look at today, you'll see that early on we just had many, many disastrous project failures where they were just not managed well. And the problem, they would come in way over budget or they would come in way over time. At one point in time, I read a research paper that said 75% of all IT projects come in either over budget, over time, or not doing everything they were set out to do. So in other words, some type of a failure. Not necessarily a total failure, but a partial failure to some degree. 75%. That's huge. That is huge. So think about that. And of course then if you go to the Project Management Institute website or you do any reading, you'll find something called the PMBOK, Project Management Body of Knowledge, PMBOK. We call it PMBOK. And this PMBOK is a set of standards that that we use for project management that tells us what are the roles of a project manager. And what you find is that a project manager has to be a great manager of people and motivator, but they also have to be a great organizer and very good at allocating and budgets and time and milestones and keeping you on track and making sure all of the resources are there that you need to work with. It is a huge job, but a successful project manager is in very high demand today. So read what your book says here about a project, and then I want you to look on page 292 at another triangle. And this really is a very simple triangle, but it is a profound one. It says that the project triangle consists of time, cost, and scope, and these three sides of the triangle will determine the quality. And therein lies the problem. If the time creeps, we're no longer going to finish this project within, the deadline is 2 weeks, we're going to be 4 weeks. So we go ahead and we let the project time creep, but we don't then go over here and adjust the cost side. Or the reason the time may have crept is because we allowed the scope to get bigger. We added on some functionality or some people, but we did not take into consideration the impact on the time and the cost. If you switch the time, it's going to impact the cost and the scope. If you adjust the scope, it's going to impact time and cost. If you adjust the cost and try to make it cheaper, you're going to have to take down your scope or take down your time. In other words, these three are very highly interrelated and they work together. What often happens is one is oftentimes allowed to creep without adjustments to the other, and we end up with failure. What we've got to understand, absolutely got to understand, is these a lot of people call this the triple constraints. And these are the things that constrain us. And if we need to cut the cost down, then we're probably going to have to do it by cutting the scope down a little and bringing it in a little less time. If we need to increase the scope, then we're going to have to deliberately increase the budget and the time almost all the time. So we have these change groups. There's nothing wrong with allowing a project to deliberately change because something new has been discovered. That's okay, you can change. But what is not good is just to allow it to creep. You don't just allow creep, you make definitive changes. And you think about each change. Well, yeah, I'll add that functionality. It shouldn't be too big. Well, I don't know. Sit down and look at it. How big is it going to be? Well, on second thought, it's going to be 3 weeks and $10,000. Well, we're not doing it then. So you need a change control board or for example, So make sure you've paid attention to these triple constraints here as well. And, the elements, it's important that we have a common project vocabulary. The business people talk in terms of dollars and time to market, and sometimes IT people talk in terms of throughput and availability and scalability, and we're not on the same page. So we need to not say scalability, we need to say, how many customers or how do we expect the organization to grow? How big might we need to be? Are we going to stay the same size? Use common vocabulary, if you will. Now, very quickly, I want to mention the systems development life cycle. And again, if we decide ultimately, I'm sorry that my phone keeps ringing. My little grandson has a broken arm that's been broken for a week, and we've done multiple attempts at him. It's been a mess, but he's had 2 sets of X-rays, and he keeps getting worse. And finally, we kind of had a little fit, and today we're getting results, and we're now in a cast, and we've found 3 fractures that were not found by 2 other hospitals. So anyway, needless to say, it's wild here, and my phone keeps ringing because people are calling about it, and I keep turning it off. So excuse me for that. But I want to talk to you for just a minute. When we have this make or buy, we've been talking about buy and outsourcing. Sometimes we do decide to make, and back in the 50s when I was first talking about it, because they were proprietary systems, that's kind of what we always did. We made our own. We developed our own systems. And we had to come up with a scientific approach for doing that. So the systems development life cycle is simply a methodology for making sure that we dot all the I's and cross all the T's. There are many methodologies out there, and some of them will have 4 phases, and some will have 3, and some will have 6. They're really all saying the same thing. Some of them are just more specific as they as they describe them. But in general, they're all going to have the phase where you do systems planning, systems analysis, systems design, and systems implementation. Now, some people may break planning out into 2 phases and analysis into 3, and so they'd end up with a longer list. But they're still doing these 4 broad functions. We are planning the project, we're getting the team together, doing the budget, doing the initial feasibility studies, we're determining whether or not we should devote more money to this project, and yes, this is something that is probably feasible and needs to be done, and yes, management says, we present our business case and management says, yes, we're going to do this. That gives us the permission to move on to the next step, to the analysis phase. And then we analyze, and this is where we determine all the business requirements. What does the business what is going to be needed of this new system? What's its functionality need to be? What does it need to do? And after we've determined the what, we can move into the design phase where we get more into the how. Finally, we actually bake the cake after creating the recipe. We do it. We implement it. When we implement it, we can either do a phased implementation or a direct cutover. For example, I can say we're starting the new system today. We turn the new one on and the old one off. That's called direct cutover. Well, that's very efficient because we don't have to at any point run the 2 together, so we can use all of the equipment from one and the other if we need to. So it's the cheapest, but it's also the scariest, because if you turn the other one off and the new one on, if there's any glitch, even a minor glitch, you don't have any coverage. There's not a backup running. We can also phase or pilot. Pilot is where we go into just this department or just this wing or just that division with the whole system, and then bring it to another division and then another division as we work the kinks out. A phased is where we bring in just a piece of the system to everybody until we get it worked out, and then another piece. So we can, there are different ways to do this, but obviously this depends on the risk. In an operating room, you're not going to go direct cutover. You're going to have some backup going on. If it's, the more critical and the more costly, the more risk, obviously it's worth the risk to run them both at the same time to make sure that we don't have any failure before we, switch completely to the new. But the big picture we need to see here is that in the older days, our systems were very structured, and we were building transactional systems, and we knew what we were building. And so we could start out, planning our projects, determining our requirements, and then deciding how to do it, and then making it happen and implementing it. We could do that. And it was very rigid, and it was very sequential. The output of this became the input for this, and so forth and so forth. Notice there was no back and forth in that methodology. But now we live in an era where, we may not be able to determine the requirements right up front. Maybe I've never approached this before. Maybe I'm not sure. And these requirements are going to have to evolve as we go through the process. Or maybe I can determine them right up front, but they may change before I get the system put into place. Either way, that very rigid, very thorough, very well thought, very solid process may not be good if in a dynamic situation where either the situation's going to change or where I can't always know it right up front. And so in those situations, we use a more evolutionary approach or a more iterative approach, and prototyping is one of those, but you'll hear rapid application development, RAD. You'll hear a lot of different acronyms, but basically it simply means I may develop a few screens and throw them up for you, and you use them, and then you throw them back at me and say, well, can this be tweaked? Or, it's the way my first website was designed, because I had no idea at that time years ago what I needed on a website. And I said, I don't know what I want. Well, what color do you want it? I don't know. Well, give me a favorite color. Well, I've got on a purple dress. It's pretty. Do it that color. And then a week went by, and he sent me this thing and says, click on this and see what you think. Well, I clicked on it and I looked at it and I said, well, I don't like that, because what's that semicolon? And those letters are not very big. And how would a student find? And so I began to, and I'd throw it back at him, and he'd change it and bring it back to me. So it evolved. As I began to use it, I began to understand, you know what, Romero, this isn't going to work because I need you to add this or to take away that. So I couldn't sit down at the beginning and do an analysis phase that says I need a website that will do this, 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 and this. I had no idea what I needed it to do. That had to evolve. So I had to use a more iterative approach. So when your book talks about iterative approaches versus the very, inflexible, and so we still, if it's very structured and not going to change, the systems development life cycle is still a great tool. We just need to use the right methodology at the right time. Now, what I've done here in this lecture is kind of help you, hopefully, see conceptually. Your book gives you a lot of details, but I want you to see what we mean by outsourcing. It's just a make or buy, and it's letting someone else do part of our work for us. What are the pros and what are the cons? As a manager, IT does not make that decision. We're going to outsource our IT. No, we're going to outsource our payroll. As they present a business case to you, outsourcing may be one of the alternatives that they give you and that they discuss, but they're not going to make that. It's a business decision. And when we choose which project we're going to implement or not implement, that's a business decision. You see, business applications, and it comes from opportunities. We've either got problems, or we've got opportunities, or we've got directives. Something's broken and it needs to be fixed, so IT has to begin to address it. Or maybe the steering, and those oftentimes come from users that see the problems. Maybe the steering committee sees an opportunity, and in the strategy, we can do this if IT can do this for us. Or maybe it's a directive. You will follow the HIPAA laws. You will do that. You will do Sarbanes-Oxley. It's a directive from some agency or some authority figure or something that has the power to make you do it. But there may be, and there will be, way more requests in the pipeline than you're going to feel. Who determines which one gets done, which one gets done first? Well, management. Now, IT is part of that decision and part of making that business case. But management makes that decision. So the important thing is that you understand what we mean by architecture and infrastructure, and you understand some of the issues that are out there and what we mean by them, and what is a client server, and what is cloud computing, and why would I want to do it and why would I not want to do it, so that you can have an intelligent discussion about that with your IT people or with your other business members. And again, if you understand a little more about how the systems development process works, it might make you be a little more able and maybe a little more willing to help them as they collect your business requirements and you understand. Because at the end of the day, the system is for the user. And the IT people are developing that system for you or for the people in your department. And they cannot do that. I cannot go. I have 3 daughters. And I have one daughter that I could go out today and bring home some clothes, and most of them would fit her and suit her. The other 2, I wouldn't even dream of trying. Because, I could go buy a beautiful dress that's very well made, that's a very good price, that is a designer that anybody in the world would want. But maybe my daughter says I wouldn't wear that to a dog fight. And she's the user. She's the wearer. So you see, if I don't consult them and I don't work with them, and if they do not work with me, I'm not going to buy something that they're going to use. We have to make sure we're both understanding. And so that's why I don't have to sew the prom dress, but I have to understand what it can and cannot do, what its constraints are, and and I don't think you want that one because it's going to itch, that one's going to be hard to walk in, that one's going to be stain real easy, that one's going to be real hot. I got to understand enough about it to help make the right decision. That's what we're trying to get for you all. Architecture and infrastructure can be very technical, but it's not the technical part that a manager needs to understand. It's the conceptual part. So once more, if you have any problems, please call me. I have posted your grades for your Unit 1, and some of you have expressed concern. And I sent out a general, the bottom line. Some of you were very specific and in saying that, if we move to online, we're going to have newer technologies, which means we're going to have training, which means we're going to have different structures and maybe divisions and somebody to, for help and support. It means we're going to have to pay the professors differently because what if I develop the class and then someone else takes what I developed and teaches it next time? Who owns it? I wanted you to bring out all of these different issues that are going to come up. What would have to change in the organizational structure? And look through all of the components of the structure and talk about them. What might change? How might you address them? How might you have to adjust IT to meet that change, or adjust org strategy to meet that change? So what changes are going to come forth in IT or org strategy, maybe because of this change in business strategy? And how will you address it to make sure the triangle doesn't get out of sync? Some of you you talked about an unlimited number of possibilities, and you were very thorough about the implications. And when this does happen, the students are going to say this, or the faculty you were very good at noticing that the faculty are going to feel differently about it than the student. And some of the things the students love, the faculty will hate. And some of the things the faculty want, the administration will not be willing to give. Many of you were very articulate in understanding how the IT, understanding the whole connection. Others of you were rather simplistic and said, we'll just have to make sure Blackboard's there. Well, Blackboard's already there. Why would that have to change? You didn't tell me it was going to be changing. And you were very superficial in terms of your level of discussion, and you made very general comments, and so your grades were not quite as good. If you had a low grade, or if I thought I needed to share with you that you were missing the point, I sent you a separate email. Those of you who made a very strong grade, even those of you who made maybe a B plus or an A instead of a 90% instead of a 96%, the difference between those papers were simply level of critical thinking and amount of support you gave, and you probably introduced more of the issues. You supported your discussions better, with a more logical argument. You ended up with better recommendations, and you had seriously and very critically considered all of those implications. And so that's what I was looking for. So if you nailed it, if you did a lot of that, you might have gotten a lot of it, which means you met the requirements, you did, but there's still a lot of things that you didn't even think about. And so your grade was a little lower, and so on down. Those of you that got C's because you basically did not do this in this manner. You basically just talked about definitions in the textbook, or you talked about what the frame, the triangle or something. Didn't need any of that. I needed you to say, when USI brings on more online courses, the organizational structure will change in this manner, which will impact IT in this manner, or which might require IT to be adjusted in this manner, or when they bring online, the IT will have to adjust in this manner, which will bring forth maybe these changes in the organizational design. And so, and to avoid this, you might have to do this to the strategy. So I was looking for very specific discussion of this situation. You're the manager. This situation is happening. Now, how am I going to keep my triangle from getting out of balance as these changes come forth? So that's what I was looking for. If you want to talk to me on the phone, I'm happy to talk to you. If you want to text me, some of you are texting me without giving me your names. Please give me your names and your numbers when you text. Also, many of you are not putting your name on your paper because you're submitting it and you're assuming I know who you are. I print out a huge batch. They print out in one batch, just one after another. And they don't have a name associated with them. And it's not easy for me to go back and find that name. It takes a lot of time, sometimes more time than others. So it's very important that your name be either on every page or at the beginning of your report or on a cover page or something. If your name is not inside that file, I do not know who you are. And I have to spend a huge amount of time going in and calling them up one at a time and seeing which one looks like yours. It's a big issue. So try not to forget that in the future. And call me as you need me, and I hope you enjoy the remainder of the day.